Let's examine multiplication with fractions. So the three kind of cases we're going to break this down into as you look through our notes in the textbook. One way is through seeing it as repeated multiplication, which is a whole number times a fraction. 3/4 means 1/4 plus 1/4 plus 1/4, 3 times 1/4. Do 1/4 3 times. That's it. And 3/4, 8 times a half. It would be 8 halves, or 4. Repeated addition. Case 2 is a fraction times a whole number. So one way to think about that is first just to say, you know what? We know commutative property. Does it hold for fractions? It does. So 1/2 times 8 could be seen as 8 times a half, and then we know the answer is 4 also. So that's one way to think about it. Another way to think about it is through that we're actually taking a half of the 8. We're taking a fraction of the 8. So taking a piece or fraction. So taking half of 8 would be 4. So it's not repeated addition approach. We're actually taking it, right? We're going to take it. So one is to see it as first is to see it as a commutative property, and then I can do repeated. I could do repeated addition. We can then also interpret this as half of 8. I'm taking half of 8, which is 4. So almost like a division problem to think about it, but it's multiplication. That's where it gets confusing. Multiplication is a division problem. A third way to think about, in the hardest one, is a fraction times a fraction. What does that mean? Right? We can't use repeated addition for this. So we're going to apply technique 2, taking a piece, right? 1/3 times 2/5 means take 1/3 of 2/5, taking a piece, a fraction of a fraction. And there's an awesome visual that allows us to see that, because it's still hard to imagine. Take 1/3 of 2/5. So one way you can conceptualize it is through common denominators. I want to take 1/3, right, of 2/5. In some ways of trying to figure that out. Okay, how would I take a third of fifths? Well, if it's in group, if it's in 15s, we could do that, right? Because that would be a 6/15 technically, right? One way is 2/5 is 6/15, and if I take a third of that is 2/15. Well, we can draw this. Take a look. Here's 2/5, and then I want 1/3 of that. And so what we do is, you'll see, we end up breaking that up into thirds. And I want 1/3 of the 2/5. So that means I only want that component right there, and that's it. So 1/3 of 2/5 is 2/15, because now I have 15 little squares, regions, and I want 1/3 of that. So that's it. That's the way to think about it. So looking at the examples, we can take a look at using a diagram. There's the half. There's the 3/4. I want to take half of 3/4. Half of 3/4. So let's do, so you can visualize it. There's the 4. So my writing's not that good, but there's the 3/4 you could see in blue there. Let me recreate it. Right? There's that, right? So we have the 3/4, and what I want now is half of that. So let's go half of that. There's my half right here. This was the 3/4 component, and so the piece that's the half, the yellow part there, is here. I want half of that, but I only want half of the 3/4. So the component that is of interest is this component right there. So you could see there's 1, 2, 3 out of 8 pieces. 1/2 of 3/4 is 3/8. Pause, take a look. In the textbook, I know I have a video to further explain that, to see more examples, but that's the visual part of it. So, okay, that makes sense, which then leads to, notice, 1/2 of 3/4 is just 3/8. You do top times top, bottom times bottom, and that becomes our definition for fraction multiplication. A over B times C over D is just AC times BD. So you could see in these examples, straightforward, 3/4 times 1/5 equals 320. 2 times 1/5 is 2 over 1 times 1 over 5 is 2/5. I think in the old version of the textbook, I have a 2/3 times 3/7. So something to keep in mind. But again, this is what inspires our rule: top times top, bottom times bottom. So keep that in mind as we get through that and do multiply. Now, before we move on to division, we have a couple of things here. The wonder play grow we've done in class. So these problems are a little bit harder. So I've done A here. So you could just multiply top times top, bottom times bottom. That'd be totally fine to do. And then you get your answer. So that's one way to do it, 84 over 60. But also notice again, then it simplifies. We want to simplify that. So that totally could work. But notice here, I could have also pre-simplified 3/4 times and then simplify first. And then you end up with, so this often confuses students too when you simplify first. So you start with smaller numbers, you can just multiply top times top. But when you get these bigger numbers, sometimes simplifying first before multiplying makes sense. In this case, these just actually divide into 1. So you're just left with 7/5. So there's actually no multiplying going on technically. So that's why that could be kind of challenging. I'm not going to do them all. Look at C, mixed number. You would turn that into 7/3, 2 and 1/3, 7/3. 7/3 times 2/5, 14 over 15. So top times top, bottom times bottom. You guys can go fool around. Again, some of these you would simplify. This 39 would be 3 times 13. Those 13s would divide out into 1s. This could be 2 times 9, 9 times 8. So you want to fool around with a little bit of that as you simplify. Maybe we should do D before we finish this one here real quick. That 18 over 13 is equal to 2 times 9, and then we have 13, and then we know that 39 over 72 is 3 times 13 over 9 times 8. So when multiplying those together, I get 2 times 9 over 13 times 3 times 13 over 9 times 8. And so when we multiply that, we are going to simplify first. And when we simplify, what's going to happen is you will see here that, right, this 13 and 13 are going to say cancel, but they divide, right? That's 13 over 13 is 1. And then 9 over 9 would divide into 1. And so then that leaves you with, I think 2 times 3 over 8, which is 6/8 or 3/4. So that's what that would simplify into. So thinking about our work there, just keep that in mind there. Check my math, okay? It went kind of fast, but you got the idea of breaking into factors and then dividing out those 9s and 13s. So I think that's right. And then we leave with, of course, multiplication having properties. Anything times 1 is itself. There's this inverse property of multiplication, meaning A over B times B over A equals 1. So when you multiply those, that's by the reciprocal. That's called the multiplicative inverse, the reciprocal. The reciprocal of A over B is B over A. And so you could see then the reciprocals here, these are 9/4 and 1 over 7, because when you multiply those two fractions, it equals 1. It's such an important idea later in algebra. When we multiply by a reciprocal, if the product is 1, right, the product is 1, it allows us to simplify more complex equations later, but something to keep in mind.